Julian? How are you doing? Can you do me a favor? Log out and log back in. We got those same audio problems. Julian?
Yeah.
Yeah, that always solves it. I wonder what the heck's going on there. That's like 3 times in a row that it's been like that, hasn't it?
Yeah.
Does my voice sounds okay to you?
Yeah.
Your voice sounds like you just swallowed a balloon full of helium. Worse.
That's so
Plus,
weird.
I can't understand it even, so I wouldn't even be able to do it if I could hear it. So, okay, let's see. I believe we did number 15 last time. We ended on that?
Yeah, I think so.
Because I don't remember doing 16. But
No,
let's look at 15 again. What's going to be the measurement of these angles?
70?
Good. Both of them, yeah. They're both the same because this is isosceles. Any triangle that has 2 same sides, the opposite angles are also the same.
Okay.
Now when I say the side opposite an angle, you know exactly what I mean?
The side opposite of the angle?
Here, let me draw some triangles here.
Yeah.
the side opposite angle A?
The side?
In other words, what's this side right here?
Oh, I don't know.
Well, BC.
BC. Oh, okay.
BC is opposite A. In other words, if you take this angle A and you look at both rays, they connect to B and C. So that's how you figure out the side that is opposite an angle. What is opposite angle C?
Angle B or BA?
BA, side BA. In other words, I'm talking about a side that is opposite an angle. Okay, what's opposite angle B? What side is opposite angle B?
AC?
Okay. Yeah, you got it. Getting out of my way. All right. Let's look at 16.
Okay.
Are those two polygons similar? Study them.
So you gotta put in the ratios, right?
Yeah, what is the ratio of the corresponding sides?
5/25?
Find the corresponding side of this polygon relative to this polygon.
So by corresponding, you mean...
If I were to orient this properly by flipping it,
Okay,
it corresponds with the 2, right? It's the skinniest side. So what's the ratio?
So 10? 2/10?
10 over 2.
10/2?
It's better to, I think it's better to compare bigger to smaller because you deal with whole numbers, not fractions.
Yeah.
If you compare smaller to bigger, you got fractions. Now, their answers compare smaller to bigger, but that's okay. You can go either way. So the ratio is 5:1. Is every corresponding side 5 times bigger than its corresponding side in the smaller one?
I don't think so.
Which one is not?
Oh, wait,
You can look at the answers.
Is it 8/41? Is that not corresponding?
That's correct. So D is the answer. In other words, these are not similar because every corresponding side is not 5 times bigger than its corresponding side. 25 is 5 times bigger than 5, so that works. 30 is 5 times bigger than 6, so that works. But when we get to the last one, comparing 41 to 8, that's not 5 times bigger.
Yeah.
All right, let's look at 17. Let's draw a picture of 17. It's hard to do. Good. Alright, let's see. We have two triangles that are similar. Draw them like this. ABC and XYZ.
Okay.
And angle A is equal to angle X, B is equal to Y, and obviously C is equal to Z.
Yeah.
If AB, BC, and AC are 7, 9, and 10 inches respectively, and xy is 9, what is xz?
12.
How'd you get that so quick?
Because it just added 2 from 7.
Well, that's not the way you do it. Notice the answer is 12.9.
Yeah.
So that way it wouldn't give you a precise answer. And
Yeah.
they're never going to give you an answer that's off by 9/10.
Yeah.
Remember, this is a ratio problem.
Okay.
So what ratio can I set up with this triangle situation here?
9 over 7.
Equals what?
10 over x.
Well, it's this that we're trying to figure out, right?
Yeah.
So let's say question mark, or let's call it xz
Okay.
over 10.
Okay.
Those are the key ratios. In other words, if these two triangles are similar, then 9 is to 7 as xz is to 10.
Yeah.
So now solve this for xz.
So, do you cross multiply?
Normally you do cross multiply, but notice that that's counterproductive.
Okay.
In other words, if I cross multiplied, the next step I'd have to do is divide both sides by 7.
Yeah.
I'm trying to find line segment xz, is all I have to do is multiply both sides by 10. Notice that is one step short of cross multiplying.
Yeah.
In other words, I'm only multiplying one side by 10 and I have my answer.
Yeah.
90 over 7. That is 12.9.
Yeah.
Notice what happens if I'd have cross multiplied. I would have done this. I would have done the 10 times 90. I would have done the 7 times xz. Then I would have had to divide both sides by 7. I would have had to do another full step. As opposed to just one step by multiplying just both sides by 10. That gets rid of the denominator all by itself. Now I've got my answer. All right. Next page. This is 4, 5. I gotta go to 6, 7. Is your final tomorrow, Julia?
Part of it.
Well, at least you get to take it over 2 days. You going crazy with finals?
Yeah.
Are you in the 8th? Are you in 9th grade or 8th grade?
I'm in 10th.
10th grade. Okay, so you do have high school finals you're going through.
Yeah.
Okay. I know that's hard. Some of my students, their eyes close in the middle of a session because they're so tired from studying so hard. All right. ABC is similar to DEF. They're both oriented properly. So how can we solve for X and Y?
So the ratios again.
Uh-huh.
So x over 14 equals 5 over 8.
Good. Biggest thing to make sure you do is just always go in the same direction. I don't really care whether you go big to little or little to big. Just don't go little to big and then big to little.
Yeah.
Okay. Now how would I solve for X?
So on this one, should you cross multiply or should you times it by 8?
Just, not really. Just multiply both sides by 14. In other words, our goal here is to isolate the x.
Okay.
If I cross multiply, then I got to then divide by 8.
Yeah,
but
so...
if I just multiply by 14,
yeah.
now I'm done, almost. I'm not really done because this needs simplified, but it basically is a one-step process to do this way. Whereas if you cross multiply, it's a two-step process to get to the same exact point.
Yeah.
Now, how do I reduce that?
So, 70 over 8?
Okay. I prefer to simplify these a little bit first. In other words, I knock that down. I knock both of these down in half so that it's 35 over 4.
Okay.
Now I know that answer a little bit better. That's 8 3/4.
Okay.
They've only got, no, they got two answers that have 8 3/4. And besides that, we need to solve for y, and we never did do that.
Yeah.
So how do I solve for y? English.
Y over 7 equals 14 over 8.75.
Let's not bring decimals into it if we don't need to. What's a better ratio to use?
Okay, so
Same ratio you used on the first part of the problem.
35 over 4.
No, 8 over 5.
8 over 5.
In other words, these ratios have to be the same regardless of which side you're talking about.
Okay.
So your y to 7 was going big to little.
Yeah.
Well, here we have a big to little, and there's no decimals in that. That's just a fraction. As opposed to, I mean, what would you rather have to solve? That or 14 divided by 8.75?
The first
Yeah, it's
one.
easier to use that ratio, a lot easier.
Yeah.
And there's nothing that says you can't use it twice. So again, here I'm just going to multiply both sides by 7. I'm basically done. I can't reduce this any, so that becomes 56 over 5. And you can give that as an answer. There's nothing wrong. Well, I see. No, you can't. That's 10.2. No, it's 11.2. So it's B.
Okay.
Okay. What do we do here?
The ratios again. So 19 over x equals 15 over 97.5.
Now, this is going to work just fine, but notice I do have to cross multiply this.
Yeah.
And then I'm going to have to divide both sides by 15.
Yeah.
So maybe it would have been better to go big to little.
Yeah.
Equals 97.5 divided by 15. Notice you can go either way. You can go big to little or little to big in these ratios.
Yeah.
The advantage of doing the bottom way is that the x is in the numerator and I only have to do one step. Multiply by 19, simplify. Okay. I mean, I don't know that that particularly is important. It probably is not, but it's something that, you know, you do enough of these things and every step you save helps.
Yeah.
So let's see. This is like 19/15 times 97. So I know it's not A. It's not D. It has to be a number bigger than 97, and I can't estimate it based on these two, so you'd have to use a calculator to figure out which one it is. I'm guessing it's 130. Do you have a calculator?
Yeah.
Go ahead and do 19 divided by 15 times 97 and a half. all in one step. 19 divided by 15 times 97.5.
123.5.
Okay, my guess was wrong. Yeah. Okay.
Okay.
What kind of triangles is this triangle right here and this triangle right here?
Yeah.
What about them?
They both have right angles.
Okay, not only do they have a right angle, they also have this angle is the same. Notice that little curved line?
Oh, yeah, I see that.
Okay, so they have, how many angles are the same?
2.
Which means all three.
Isosceles, right?
No, it means all three are the same.
All 3.
Right,
okay.
because the angles have to add to 180. So if 2 of them are the same, the third one's always the same.
Yeah.
So these two triangles are what?
Congruent?
Similar.
Similar.
Difference between congruent and similar is congruent is equal.
Okay.
Well, they're clearly not equal. This one's bigger than this one.
Yeah.
But they're similar. They're exactly the same shape.
Yeah.
Because they're similar, so it's another ratio problem.
Yeah. So
what are we trying to solve for? We're trying to solve for this. How far up the wall does the shorter ladder, so here it's this that we're trying to solve.
okay. So 45 over x?
That's a good start, I guess.
Or should we do x over 45?
I like that better.
Yeah.
Equals what?
24 over 60.
Got it.
Okay, so
now, see, I can simplify this into 4/3.
Yeah.
Oh, hold on.
Okay.
What did I do? Sorry. I didn't mean to do that. Equals 24 over 60. I have to multiply both sides by 45, not by 60.
Okay.
So that's, and now this becomes 3 over 4, and that 4 goes into that 6, so the answer is 18. Notice by simplifying it, let's examine that a little bit, because I noticed none of my students like to reduce these. They all want to multiply the numerators and multiply the denominators and then go from there. It's probably because you're going to do this on a calculator and so you don't care.
Yeah.
There's nothing wrong with that, but let's make sure you know how to simplify these. I know that 45 is divisible by 15, so is 60. 3 and 4. Now I've reduced the size of the numbers considerably. I also know that 4 is divisible by 4 and 24 is divisible by 4 6 times. Now I don't have to have a calculator.
Yeah.
So when you can simplify stuff, it's really advantageous. So, I mean, I guess in a calculator world, that's a skill that is not needed a lot of times, but okay. They want the measurement of angle CED.
Okay.
What do we know about ED and AB?
Well, ED is like the midpoint.
See this right angle here?
Yeah.
This right angle here?
Yeah.
What does that tell you about ED and BA?
They are similar.
They are parallel.
Oh, parallel.
Notice what this is if I turn it on its heel.
Yeah.
Well, let's see. If I turn it straight top to bottom, like this, and I draw that midline, and I tell you that that's a right angle and that's a right angle.
Yeah.
Well, remember two parallel lines and a transversal? Yeah. If this angle is equal to that angle, those two lines are parallel by definition.
Yeah.
So what I have here, here's my parallel lines, here's my transversal.
Yeah.
The fact that this angle is equal to this angle here means that we have parallel lines. This line has to be parallel to that line.
Yeah.
Because these two angles are equal. Only because of that.
Okay.
Okay? Now, the fact that that line is parallel to this line, there's another transversal. There's this transversal.
Yeah.
What does that mean about angle A and angle B?
They're the same.
So what is this angle right here?
51.
Yep. Now, they put numbers 12 and 14 on there.
Yeah.
Not sure why. We didn't need it.
Okay.
Didn't use those numbers.
Yeah.
The only thing that mattered was that that was a right angle, that's a right angle, therefore ED is parallel to BA. Since ED is parallel to BA, this angle is equal to this angle.
Okay.
Okay, number 22. Here they tell you that PQ is parallel to BC. Find the length of AQ.
Okay. So, is it the ratios?
Uh-huh.
Alright. So, we're trying to find AQ?
Yeah, we'll call that X.
Alright. So, 10 over 12
Okay.
is equal to X over 18?
That happens to be true, but that's not really the way that I like to see you do it.
Okay.
What we want to do is compare corresponding sides. So the ratio is 18 to 12.
Okay.
18 to 12, the known two numbers, must be equal to X over 10.
Okay.
Okay? Turns out that that's the same thing you gave me. Notice you gave me 18, or you said 10 is to 12,
Yeah.
X is to 18. Well, notice if I cross multiply both of these, I get 12x equals 180. This one gives me 12x equals 180. So x is equal to 15 regardless of which way I do it.
Yeah.
But conceptually, you want to compare this ratio of this to this with this to this. Happens that it's the same as comparing this ratio with this ratio.
Yeah.
But might be a subtle point that's not even worth pointing out. So.
Yeah.
All right, coming down the home stretch here. which one of those is a kite?
B.
Yeah. Which other one?
D maybe?
Isn't A a kite?
A.
Notice that the definition of a kite is that these two sides have to be equal and these two sides have to be equal.
Yeah.
Well, that side's equal to that and that side's equal to that.
Yeah.
So it seems to me that A is also a kite. I'm sure the answer they're looking for is B.
Yeah.
But I think A is also a kite. I might be wrong, but
Okay.
how about 24? Which statement is false? All rhombuses are kite. Well, A is definitely a rhombus.
Yeah.
Are all rhombuses kites? What's a rhombus?
Two sides are the same and the other two sides are the same?
No, that's a parallelogram. A rhombus is four same sides.
Four same sides.
Four same sides. That is a rhombus. This is a rhombus, A.
Okay.
A looks like a square, but we don't know if it is. They don't put any right angles on A. So the best thing I can tell about A is that it's a rhombus.
Okay.
Well, rhombuses are kites. So that statement is true, and it also makes their answer to problem 23, there's two different answers.
Yeah.
Let's see, are all squares rhombuses?
Yes.
Yep. Every kite is a rectangle.
Yeah.
Is that a rectangle?
No. Well, wait, no.
No, every kite is not a rectangle. A rectangle has to have 90-degree angles. In other words, a rectangle is automatically, these are 90, all four of them.
Yeah.
And kites, you can have no right angles.
Yeah.
I think this is funny because 24 directly contradicts 23. Right? In other words, there's only one false statement in 24, and it's C.
Yeah.
D is true. All squares are four-sided figures. That's all a quadrilateral is.
Yeah.
And A is true. All rhombuses are kites. If all rhombuses are kites, that's definitely a rhombus. Therefore, it's also a kite.
Yeah.
But so is B.
Yeah.
Okay. 25. Which statement is false? Every square is a parallelogram.
No, that's true.
Okay. Some rhombuses are rectangles.
That's true.
Sure, I can draw a rhombus that is a square. Notice that for a rhombus to be a rectangle, it has to be a square.
Yeah.
But that's okay. A rectangle, it's still a rectangle. In other words, the definition of a rectangle is a four-sided figure with all 90-degree angles. And the opposite sides are equal to one another. In other words, this is equal to this, and this is equal to that. That's a rectangle. It also happens to be a square, but you can still call it a rectangle. Squares are rectangles. Rectangles are not necessarily squares, but squares are necessarily rectangles. Every rhombus is a quadrilateral.
Yeah, that's true.
Okay. Every parallelogram is a rhombus. Must be the one that's false.
Yeah.
Well, let's see. The way to prove it's false is to see if we can draw one that is not a rhombus. There's a parallelogram. Definition of a parallelogram is opposite sides have to be parallel and equal.
Yeah.
This certainly is not a rhombus. A rhombus is 4 equal sides.
Yeah.
No, that one is not equal to that one.
Yeah.
All right. And 27. Choose the statement that is not always true. For an isosceles trapezoid, the diagonals are congruent. Well, let's first of all draw an isosceles trapezoid. An isosceles trapezoid is like an isosceles triangle, only it's a trapezoid. In other words, that side's equal to that side.
Yeah.
Are the diagonals congruent?
Yeah.
Okay, they are. Are the base angles congruent? The base angles being this one and this one.
Yeah.
Are the diagonals perpendicular?
Yes.
Look at them. Are they perpendicular to each other?
Yeah.
You think that is a right angle?
Yeah.
No, it's not.
No.
It's way obtuse. This angle right here, same as this angle here.
Yeah.
And think about drawing it in a slightly different way. Elongate it.
Okay.
Now the diagonals will even be less perpendicular.
Yeah.
Notice how not perpendicular they are now.
Yeah.
I mean, this is a real tiny acute angle, and that's about a 140 degree angle. Not even close to perpendicular. So if you have something like that and you're wondering whether it's perpendicular or not, don't just draw it in one scale like that, because I'll admit the way I drew that, that could be construed as looking perpendicular. In fact, I could draw it even shorter scale where it really would look perpendicular. If I draw it really close together like that, now those almost look perpendicular. But that's not enough to decide they're perpendicular. If you really want to see if they are, draw it in this mode here, and you'll see for sure that they're not.
Yeah.
And that's usually the way to handle any kind of problem like that, is don't just draw it at one scale to determine. Okay, so let's see. We got that one. Diagonals are not always perpendicular. And that's why it said not always, because sometimes they can be. Okay, 28. Which statement is true? All quadrilaterals are squares.
Yeah, that's true.
Here's a quadrilateral. Is that a square?
Yeah.
A quadrilateral is a four-sided figure. That's a quadrilateral. Is that a square?
No.
Okay, so that's false. All quadrilaterals are not squares.
Yeah. Okay.
The way to do these is to try to draw something that is not a square and still a quadrilateral. In other words, this kind of goes back to proofs. For me to prove this is false, all I have to do is find one quadrilateral on the planet that isn't a square. That's all I have to do. The moment I do that, I can say that has to be false.
Yeah.
All rectangles are squares.
That's false too.
Okay, because I can draw a rectangle that's not a square. There's a rectangle that's not a square.
Yeah.
All parallelograms are quadrilaterals.
All parallelograms are I think that's true.
It is true.
Okay.
But all quadrilaterals are not parallelograms.
Yeah.
There's a quadrilateral, and that's not a parallelogram.
Yeah.
Okay. Which triangle is not similar to any of the others?
D.
Very good. Because why?
Because that degrees, it's 50 degrees, not 60.
Right. The reason these three are similar to each other is because that's a right angle and that's a right angle, which means it makes that angle 60 and that angle 30.
Yeah.
And since two of the angles are the same, they're similar automatically.
Yeah.
In other words, they don't tell us that that's a right angle there, but it is.
Yeah.
In fact, you know it's a right angle because these two are complementary. That has to be 90.
Yeah.
All right. Which statement is false?
Is it ln is greater than np?
I can't believe this. They have... Interesting. Are these similar triangles?
Yeah.
Based on what?
Actually, maybe not.
Definitely not.
Yeah.
Because they tell us this one's 120 and this one's 135.
Yeah.
Well, this is the same as this, and this looks like it might be the same as that, but it can't be.
Yeah.
Because they have to add to 180. So if this one is the same as that one, these two are not the same. But the fact is that we found one angle that's not equal to the other one, and they're both obtuse. So these cannot be similar.
Yeah.
That's why this is an interesting problem. Now, let's see if we can figure out the solution. If I were to make that line parallel so that this 120 degree angle was the same as this 120 degree angle,
Yeah.
now the two triangles would be similar.
Yeah.
Well, in fact, they'd be congruent.
Yeah.
They'd be congruent based on side, angle, side.
Okay.
Right? In other words, we have side, angle, side is the same as this side, angle, side.
Yeah.
So if this was 120 instead of 135, Ln would be equal to NP.
Yeah.
When I change that angle to 135, what does it guarantee?
That... I don't know.
Well, let's look at it again. Let me go through that logic again. It's a little bit strange because I didn't quite draw it right. Let me draw it more properly. Now, I'm saying that if that was 120 and this was 120,
Yeah.
and that's equal to that, and this is equal to this, They would be
Okay.
congruent triangles, and
Yeah.
Ln would be equal to NP, correct?
Okay. Yeah.
Because congruent triangles, corresponding sides are equal.
Yeah.
So now everything is exactly the same except this angle is 135.
Okay.
What happens to NP in order when I extend that to 135?
It gets a little longer.
So doesn't Ln have to be less than N?
Yeah. Okay, yeah. So it's C?
Yeah.
Okay.
If this angle was shorter, let's say it was 110 instead of 135, then I would have to make that line like that, and NP would be shorter than Ln.
Yeah.
That's why this is a fairly clever little problem. It really kind of requires you to, I don't know, think out of the box a little bit.
Yeah.
So OE bisects that angle such that got a little angle there equal to that little angle there.
Yeah.
And EA is perpendicular to OA. Well, they show us that. They show us a right angle there. And EB is perpendicular to OB, so we have a right angle there.
Yeah.
So, which statement is not true? Is line AE congruent to BE?
Yeah.
Based on which postulate?
Side. Side angle side.
I don't see two sides that are the same. The only side I know that is the same is OE, is the same for both triangles.
Yeah. Okay.
But I know angle, 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 angle. How about angle, angle, side? Angle,
side.
angle, side. Notice that angle, angle means angle, angle, angle. So if you have one side that's the same, you have to have congruent triangles. If you have angle, angle, angle without a side, then you have similarity. But to have congruence, angle, angle, side proves congruence. We know that these are congruent. Therefore, AE is congruent to BE.
Okay.
Now let's look at B. Is angle AOE congruent to EOE? EAO.
Yeah.
AOE is that little angle right there.
Yeah.
Is it congruent to EOA? It's the same angle. That's funny.
Yeah.
Okay, so it is. Sorry. OA is congruent to OB.
Yeah.
So the last one must be the one not true. AEO is not congruent to BEO. Why not? Yes, it is.
Yeah, I know it says it is. Oh, what? I don't know. Whoa, that's weird.
AOE is congruent to E. I read B wrong. AOE is this little angle with the hash mark.
Yeah.
But EAO is that right angle.
Oh, so no? So it's B?
Right. I read that as EOA, and it's EAO.
Okay.
Which graph represents a reflection over the x-axis?
B.
Good. Which graph is a reflection over the y-axis?
C.
Okay. What's this called? A.
No, a translation.
Translation, exactly. What's D called?
A rotation.
Good. A rotation and a translation.
Yeah.
Because if you merely rotate this, it doesn't end up here. So you have to translate it and rotate it. All right. All of these answers, or most of those answers, have to do with parallel or perpendicular.
Okay.
Now, at a minimum, we need to figure out the slope of each of these.
Okay.
Right? In other words, in order to answer questions about whether they're parallel or perpendicular, we got to figure out what the slope is.
Yeah.
However, before we do that, notice something about these two equations. No, my mistake. No, forget that. I was going to say, the second equation looks like a multiple of the first equation. Does it not? It is. I've left out the minus sign. Wow, that's weird.
Yeah.
That is really weird. Because I looked at my writing and thought that there was a multiple of it, and it wasn't. But once I put the negative sign back in where it was supposed to be, it is.
Yeah.
Right? Every term is 6 times the other equation.
Yeah.
30 is 6 times, or minus 30 is 6 times minus 5, minus 48 is 6 times minus 8, and 24 is 6 times 4. What does that mean?
Yeah.
What does that mean about equation number 2?
That.
It's the same line.
Yeah.
That's it. It's the same line. Remember, I can do anything I want to an equation. I can multiply both sides by any number I want.
Yeah.
So if I take this line and multiply the left by 6 and the right by 6, I get this line. Well, you don't change the line by multiplying it by 6. It's the same line.
Yeah.
So B is the answer. We could have spent a lot of time solving this thing for y.
Yeah.
Y would be equal to minus 5x minus 4 divided by 8.
Yeah.
This y would be equal to minus 30x minus 24 all divided by 48.
Okay.
So if we were to compare slopes, the slope, if we didn't notice that one line was exactly 6 times the other, and we set about solving for slopes, well, this slope is minus 5/8.
Yeah.
This slope is minus 30 over 48, which is also minus 5/8. So if that's all the work I did, I would see, well, that is parallel to that.
Yeah.
And I might answer it wrong at that point.
Yeah.
So this is a very tricky question. If you go about solving this the way most people would, you're probably going to answer C immediately. The moment you discover the slopes are the same, you say they're parallel, boom. But they're not, because they're the same line.
Yeah.
And a line that's the same line is not considered parallel to itself. Even though technically I suppose you could say that. You could say that a line is parallel to itself. I mean, parallel is really the same slope. They got a lot of questions
Yeah.
on this test that there's more than one right answer, I think.
Yeah.
It's hard to argue with C as an answer. They are parallel.
Yeah.
Because the definition of parallel, I think, is that they merely have to have the same slope. I don't think they have to not be on top of one another, but maybe. I might be wrong there, actually. Okay, well, good timing. How'd your mom know that we were going to get through every one of the questions right as we ran out of time?
I don't know.
All right, which best describes the relationship between the line that passes through those 2 points and the line that passes through those 2 points?
7 and 1 and 10 and 5.
Okay, what's our goal here?
To find the slope.
Yep. What's the slope of the first line?
So we gotta do, so wait, does it matter which points I use?
Well, yeah, you have to use these 2 points up here.
Okay.
In other words, you can't mix them with these points. They're separate lines.
Okay.
This
Alright.
line goes through those 2 points. The other line goes through 2 different points.
Yeah.
So what's the slope of this line?
Is it 3/4?
It's rise over run, not run over rise.
Oh, so 4/3?
Uh-huh.
Okay.
And the other slope?
4/-3?
Not negative. In other words,
About
the rise
3.
is 9 minus 5 over minus 5 minus a minus 8. That's also 4/3.
Okay.
So, either they're the same line
Yeah.
or they're parallel.
Or they're parallel.
Okay? So
So
the question is, how can we tell whether they are the same line or they're parallel lines? Well, I guess we need to come up with the equation of the line, because I don't think we can automatically assume they're not the same line. Notice that if I had one line that goes through those 2 points up there,
yeah.
well, it might go through the other 2 points down here.
Yeah.
So I can't assume that they're different lines. It might be the same line. The only way I'm really going to be able to prove it is to come up with the equation of the top line, the equation of the bottom line, and see if they're the same equation.
Yeah.
Okay, how do we come up with the equation of the top line, knowing the slope is 4/3?
Oh, we gotta find the
Let's put it in point slope format.
So y equals
Well, how about just putting it directly into point slope format for comparison purposes? Do you know slope point format?
I don't think so.
You don't know the y minus y1 equals m times x minus x1? You haven't been taught that? Okay. Then we'll use yours. Y equal mx plus b.
Yeah.
How do I solve that one for b?
You got to put it back in the equation.
Well, pick one of the points
Okay.
and substitute it for x and y.
Alright, so with which one would be easier?
Probably this one, the smaller number.
Yeah. Okay. So 1 equals 4/3 times 7 plus b.
So that's 1 minus 28 thirds equals B.
Okay.
Just leave it like that for a moment. That may be enough to tell they're different lines. And now let's solve the second one. The second one is y equal 4 thirds x plus b, but it's a different point. So let's pick this one, smaller numbers. So 5 equals 4 thirds times 8 plus b.
Okay.
So here our b is 5 minus 32 thirds.
Yeah.
That is about minus 32 thirds is more than 10. So this b is about minus 5 and 2 thirds. This b, well, that would be 3 thirds minus 28 thirds. That would be minus 25 thirds. That's more than 5. That's minus 8.
Yeah,
These
so
are
they're
different,
parallel?
so they're parallel, not the same.
Okay.
Finally, at 9 o'clock perfectly, which figure is not a regular polygon?
D.
Well done.
Okay.
Julian, good luck on your test. I
Yeah.
will probably talk to you after the holidays, I imagine.
I think we have another session on Wednesday.
Oh, I'm glad I asked. Yeah, we do. Oh, your final isn't until the next day.
Well, no, I have it tomorrow and Thursday.
Okay, okay.
So it's 2 days long.
Okay,
So.
you might mention to your mom that we might need more material if she has it.
Okay.
Because we just finished all 9 pages that she sent me.
Yeah.
I will talk to you on Wednesday.
Okay.
All right, bye-bye.